All right, and welcome everyone to RSC's Adventures in Academics. Today, the subject we're going to be looking at is mathematics, and this is our very first official webinar. Right, whether you're joining us live now or whether you're watching the replay, I'd like to offer you a warm welcome. All right, good day everyone and welcome back. I apologize for the minor technical hiccup, but I do believe that everything is well and truly underway. Now we should not have any problems like that in the future to come. So welcome again for all of those who joined in the brief introduction. My name is Ryan Medford and today I'll be your host for this episode of RSC's Adventures in Academics. The subject we're going to be taking a look at today is maths, and the topic we're going to be taking a look at is set theory. But before we get into that, I'm going to take a brief moment to just speak to you all a little bit about what we're attempting to do. You know, what's the goal of this whole thing? So RSC's Adventures in Academics, at least for this period via the webinar, our goal is four main things. Firstly, we're going to be distributing teaching lessons via the webinar format itself. So we have some videos that are being produced by students. Right now, we have enlisted the help of the Trinidad and Tobago Medical Students Association, the TTMSA. So we have some medical students producing content for us. These are content videos and some topics, different topics in different subjects. We have maths, bio, chem, phys, etc. So all of these videos will be coming to you all throughout the course of the month. Additionally, we have some quizzes. So the quizzes are built based off of the same topics that we'll be teaching, and they're based off of the topics per webinar. So as the webinar progresses, you will see that we'll administer some quizzes to you all. You click on the link, it'll come up right in front of you. You click on the link and it'll carry you straight to the page with the quiz itself. Now, the page with the quiz itself, you fill out the form, fill out the quiz, and when you finish, it will automatically mark it and give you back your marks. So makes life very easy. We additionally will be having some notes distributed to you all. So what you might be able to see is some notes on your screen right now. That might just be labeled sets. It should be a PDF. You should be able to click it and download it. For those of you in chat, feel free to do just that. These notes are just a supplement to the learning that we're going with. And finally, we're going to have some live teaching sessions, and that's based entirely off student feedback. So if you all would like to have teaching in a bit more detail on a particular topic or particular subject, feel free to let us know. Finally, what I didn't talk about yet is that we're going to have a live and active forum. So in this forum, students are available to ask any questions that they would like to ask, and we will have an active group of students as well as some teachers as well on the forum to answer any questions that you might have, make you feel comfortable with the work. So with all that out of the way, let me just take a moment to thank our partners, the Trinidad and Tobago Medical Students Association and APS-TT, that's the Association of Principals of Secondary Schools in Trinidad and Tobago. Let's get right into our topic for today then. And our topic for today is set theory. Now, set theory is one of those topics that comes on almost every paper, multiple choice and also the long form paper. Right? So paper 1 and your paper 2. And it has come in almost every year from 2019 go back. So it's important that you know it. But the good news is that set theory is something that is fairly simple to understand. And once you go through these lessons, I hope that it'll all be made available to you. You know, you'll all understand it perfectly. So to kick us off then, what I have here is some videos that were prepared for us based off notes from Dr. Fayed Ali, a maths teacher. And I hope you all understand and enjoy.
Set theory is a branch of mathematics that involves collection of objects. When objects have a common characteristic, they form a set. In describing a set, we use language that is clear so that there is no doubt in identifying its members. A set is a clearly defined collection of objects. Some examples of sets are as follows: the set of vowels of the English alphabet, the set of planets in our solar system, the set of black cars, the set of boys on the school's football team, and the set of girls in Form 5 at school. The first two examples are readily identifiable and can be listed. The set of black cars can also be identified even though we do not have information about all its members in terms of their location. What is important is that we can differentiate between the cars that belong to the set and the cars that do not belong to the set. The members of a set may be unknown, but once the description is not vague, it is well defined. When describing sets, we use curly brackets to replace the words "the set of." For example, the set of all the whole numbers from 1 to 10 inclusive is written like this, where the words "the set of" is replaced by curly brackets. The set of figures bounded by 4 straight lines is written like this, and the set of multiples of 5 is written like this. Let us look at the example. Does each of the following describe sets? A. Tall girls in Form 6. B. Girls in the school choir at Valley Government. C. Men who can sing well. And D. Boys who are good at sport. Only B is clearly defined, and hence only B describes a set, which is girls in the school choir at Valley Government. A, C, and D that describe tall or who can sing well or good at sports are all relative terms and not clearly defined. The statements A, C, and D can be reworded to describe sets. For example, instead of saying tall girls in Form 6, we can say girls who are over 160 centimeters tall. Instead of saying men who can sing well, we can say men who have auditioned for the church choir. And instead of saying boys who are good at sports, we can say boys who are members of their school cricket team. Each of the above statements is now clearly defined and describes a set. A set must be defined in such a way that there is no hesitation in deducing whether or not an object belongs to the set or does not belong to the set. Every collection is therefore not a set. A set is usually named using a capital letter. If we are speaking of the set of students in a school who study Spanish, then we may choose to name the set S, where S is described as follows. S is the students at our school who study Spanish. The following are examples of sets named by letters of the alphabet. A is multiples of 10. B, words that begin with the letter P. C, members of the school's football team. And D, red sports cars.
Now let's talk about the number of elements in a set. The number of elements in a set, let's say A, is called the cardinality of the set, and it's expressed as n of A. For some examples, the set A containing M, N, and P has 3 elements, or n of A is equal to 3. The set B, containing cherries, plums, mangoes, and oranges, has 4 elements, or n of B is equal to 4. Finite and infinite sets. If a set is comprised of a countable number of elements, it is called finite. If a set has infinite number of elements, then it is called an infinite set. It is not possible to count the number of elements in an infinite set. Hence, it is not possible to state the cardinality of an infinite set. Even though we may think of the cardinality of an infinite set as being infinity, infinity is not really defined as a countable number. The null set, or the set with no elements, is considered to be a finite set and has a cardinality of 0. So let's look at some examples. An example of a finite set may be the vowels in the alphabet, that is A, E, I, O, and U. Now, as you can see, there's only 5 elements in the set, and so the set is finite. An example of an infinite set may be the multiples of 3. There are countless multiples of 3, and so the set is infinite. Notice that in this set, there are 3 dots at the end that indicates that the elements of this set continue forever.
Alright, so I hope that everyone found that interesting, and I hope that it's a good introduction into the theory of sets. Now that we all have a bit of an idea as to about set theory, I suppose, I'm going to post something called an offer. Now, what the offer is that quiz that I was telling you about before. As you can see, it should have popped up as a clickable link. It's just simply labeled Q, a big blue button labeled Q. So feel free to click the Q. That should carry you to the quiz, right? Now, in the interest of time, I'll allow you to do the quiz now, right? And so I'll give you all, let's say, 3 minutes to do that quiz. So good luck, and feel free to send in your results when finished. All right, that was about 3 minutes, maybe a little bit more. If you haven't completed the quiz in this time, don't worry. You can always do it after because it's automatically marked, right? So for those of you who haven't finished, not a problem, right? So I'm just going to take that down for now. Take this moment, of course, to remind you all that the notes that follow along with this lesson are available for download, right? You should see it as sets, just a PDF called sets. And the notes are again taken from fastpassmaths.com. That's from Dr. Fayed Ali and Ms. Shireen Khan. We partnered with them. They're giving us a lot of help in resources and in teaching lessons. So now that we've covered the first piece of our introduction to sets, let's move on to a little bit more in terms of the complexities.
And now let's go on to talk about empty sets. If a set has no elements, it is called an empty set or a null set. For example, if all the students in a class are taller than 120 centimeters, then we can define an empty set, let's say G, as the students in the class whose heights are less than 120 centimeters. Since there are no members in the set G, we say that the set G is an empty set. The following are some more examples of empty sets. The prime numbers from 8 to 10, days of the week that start with the letter L, and integers that lie between 10 and 11. Universal sets. Sometimes it is necessary to classify a set as belonging to a larger or more inclusive set. For example, the set of capital cities in the Caribbean can be said to belong to the set of capital cities throughout the whole world. So universal sets are not unique for a given set, but in all cases, members of a universal set must contain all members of the set we are making reference to. The universal set can be represented by a capital U or this symbol. Sometimes we may be asked to construct a universal set for another given set. For example, if we are given the set rectangles, squares, trapezoids, and kites, we may get the universal set quadrilaterals. Or if we are given the set 2, 3, 5, 7, and 11, we may get the universal set prime numbers. Now let's look at set builder notation. Set builder notation is a simple and convenient way of describing the elements of a set without actually listing out all of its members. This is especially useful for a set that has large or infinite number of elements. Set builder notation is also useful to describe an interval on the number line comprising of real numbers. Sets comprising real numbers are examples of infinite sets that are impossible to list, and thus set builder notation is absolutely necessary in such situations. So using set builder notation, we can describe elements like this. The set of all values of x, such that x is greater than 5, and x is the member of the set of integers. And so the set builder notation for this is shown. The set of all values of x, such that x is greater than 5, and x is the member of the set of integers. Another example is the set of all values greater than -2 and less than 2. So this is shown in set notation here and also on a number line. So in summary, we can describe sets in 3 ways. Firstly, we may use words. For example, the set of multiples of 2. Then, we may list out its members in brackets, as seen here. And finally, we may use set builder notation, as seen here.
All right, so That was another look into some of the theory behind sets, of course. This time we're going into a little bit more detail in terms of the notation that questions will most likely ask you to use and most likely ask you to represent things with. So, yet again, I'm just going to remind you guys that the notes to follow along with this present, you should see it as sets, as a downloadable PDF. And I'm really stressing this because I want to make sure everyone has the notes downloaded, available to reference. If at any point you might feel a little bit uncertain, you can always go back and look at it. And these notes will serve you well from now all the way until the exam. At any point, if you might not want to necessarily look at the video again, you can definitely download the notes. The notes will all be available for download if you don't get them here on the website, right, which will be linked to you, of course. So now that we have a bit more of insight as to the theory behind sets, we all know that maths is a kind of top subject, where you could learn all the theory behind it, but unless you see it used somewhere in actual practical application, it's kind of useless, right? Because you don't really know how you're going to use it. How are we going to apply it to an actual past paper question? So that's the next thing we're going to do. We're going to take these concepts and we're going to apply them to past paper questions. Now, these past paper questions have been done by, again, Dr. Fayad. And today, the question that we're going to be taking a look at is from June 2016. It's question 3. It's based on set theory. And so I hope that you all will get a better understanding of how to apply set theory to a different situation, scenario, in this case, a past paper question.
Question 3, Part A. The Venn diagram below shows the number of students in Form 5A who have visited Canada, marked as the set C, or Dominica, which is marked as the set D. The question Part 1 asks, how many students have visited Dominica only? Let us look at the set. The Venn diagram shows the students in Form 5A, as we said, who have visited Canada or Dominica. Now we can see that 3 students visited Canada only, 10 students visited Dominica only, and X students visited both Canada and Dominica. On the outside, we can see that 2 X students did not visit either Canada or Dominica. The number of students who visited Dominica only is 10. So the answer to Part 1 is 10.
Right, so as we see, we implement the more complicated set of notation. In this case, we're using the Venn diagram, right, which is the most common form of how we would represent sets, and it's what you'll probably see in all your questions. So now we're just going to move along to Part B of the question.
In question Part 2, we are to write an expression in terms of X to represent the total number of students who visited Canada. The total number of students who visited Canada will be 3 plus X. Remember that 3 students visited Canada only and X visited Canada and Dominica. So, if we are asked to find the number of students who visited Canada, it will be 3 plus X.
Right, and that was Part B. Very simple, very straightforward, very easy. I hope everyone is following along with us. No one is left behind. I don't want anybody left behind. And I just want to take this moment to, again, just speak to you all and remember that in CSEC, in a lot of topics and a lot of subjects, what is being asked in a past paper question will often have a main topic. Yes, in this case, we're looking at set theory, but it'll often build on a lot of the previously taught knowledge. And what do I mean by that? I mean things like algebra. Now, this is very, very basic, right? This is the most simple example that I can think of in terms of adding a second, like a subtopic, right? But oftentimes, questions will ask you to look at a certain topic and also build upon your previous knowledge. So it's important that you don't just learn specific topics only for that question in particular, but that you need to have a good general understanding. And so to some extent, that's what we're trying to provide again with these videos and these webinars. You get an exposure, yes, to the topic itself, but you also get an exposure to how different subtopics could be blended together and how they may present in a question. So let's wrap this up with the last part of question 3 from June 2016.
In part 3, we are told that there are 25 students in Form 5A and we are to calculate the value of x. The total number of students in all of the subsets will therefore have to be 25. So let us now total the number of students in all the subsets. That will be 3 plus x plus 10 plus 2x, which will have to be equal to 25. The left-hand side simplifies to 3x plus 13, which is equal to 25. 3x will therefore be 25 minus 13, which is 12, and therefore x is equal to 4.
All right, and so just as simple as that, that's an entire question. That's a whole question in a past paper solved in minutes, right? And I'm sure that now you all have seen it in action. You can do it just as easily, right? And moving forward, I really want everyone watching to get the confidence to be able to walk into the exam and be able to solve questions just like that with no worry behind it. So that more or less brings us to the end of today's presentation. One more time, I'm going to remind you all that the notes for today's session are available as a download, a PDF download. It's called Sets. You should see it being shared on your screen. And today's lesson, we only really covered the first 3 pages or so. So today was an introduction into sets. The next webinar we'll be having will be to conclude the theory behind sets, as well as to offer some more questions via our quizzes. And lastly, we'll go through some more past paper questions so we get a better understanding. Finally, if you have any questions about today's lesson or any other lessons, feel free to go to the forum. And at the forum, ask away your questions. We'll be happy to assist in any way that we can. We'll be happy to answer in any way that we can. We're trying to give you all the support that we can moving forward. So thank you very much for joining me today on this pilot broadcast. Apologies again for the hiccups at the start, but thanks for sticking with it. And I wish you all the best in your studies and education.